So, I mean, this is the most difficult level in from Calc 1, okay? And there's not one like this in your homework when I'm assigning you. I have it written down. I'll give it to you in a minute. But it is something I would say I would put on a test. And again, I will show you my old exams, right? And you're going to do them all. So on this one, how am I going to start, Ryan? What's your initial thought on this? Yeah, there's a clear inside, right? So we're gonna try, and we don't know if it's gonna work. U is 4x minus x squared, and then du is going to be 4 minus 2x quantity dx, right? I want to make sure that dx is applied to that whole phrase there, that whole expression. So now if I do that, so look, I need a negative 2x. I've got just an x. Can I get a negative 2x? Well, hell yeah, if I multiply the numerator by negative 2, but then of course I have to cancel it with a negative 1/2. So I don't know if this is working yet, but I know what I can do. Because remember, what I'm trying to do is get a 4 minus 2x in my numerator, right? Because that's going to be that in combination with dx is going to give me du. All right, well, if I simplify that, upstairs now I have negative 2x minus 4. Well, that's pretty close, right? That's pretty damn close to what I want. But I want plus 4, right? I don't want minus 4. I want a plus 4, right? So what I'm going to do is add nothing. So I'm going to add 8 to get my plus 4 and subtract 8. I've added 0. So I first multiplied by 1, then I added 0. If I simplify upstairs now, I've got my 4 minus 2x, which is what I wanted, and then I got another negative 8. And I'm writing them kind of spaced out like that, because what I'm going to do is divide and conquer. I know my u sub piece will work with the first half of my numerator, and then I'll figure out if the second half of the numerator will work, right? So, Noah, tell me if you can see this. If I do something like that, can you see that color?
Yeah.
Okay, so that's me saying I'm going to divide and conquer it with the piece I know works already, and the piece I don't know what to do with yet, right? So I've got minus 1/2 of the integral of 4 minus 2x all over square root of 4x minus x squared dx. That's my first integral. And the second integral, if you see, I'm going to get a negative 1/2 of 8. So I'm going to get 4 times the integral of 1 over the square root of 4x minus x squared dx. So I did kind of a couple steps there. You don't have to do that. You're allowed to just skip as many steps as you want because you're in Calc 2. I know you know how to do algebra, right? But if you're getting things wrong, you may want to stop doing things in your head, right? Do you see what I did in my head there, though? 1/2 of 8. Yes? Right? 1/2 of 8. Double negative, canceled. So when I divided and conquered, I simplified a little bit. You don't have to do that. Okay, well, at this point, I'm going, well, I've got 2 integrals to do. Let me work on them separately because it's a lot less writing. So I call the first one hashtag and the second one asterisk, right? And I just work on those 2 pieces. So when I work on hashtag, my work is really done because I have already realized that upstairs now I have du and downstairs I have square root of u. Is that agreed? Yeah, everybody? Yes? Daniel, yes? Well, that's just a power rule, right? That's minus 1/2 of u to the minus 1/2. And I'm adding 1 to the power, dividing by the new power, And I'm not going to bother with plus c until the very end. I know there's a constant of integration, but who cares right now? So it looks like I get negative 1/2 u to the 1/2 over 1/2. So I get negative square root of u. So that's square root of u is 4x minus x squared, right? So there's the first part of my integral. Ryan, everything okay here? Yep. So now comes the part where the inverse trig comes in. So I've exhausted everything on my list in this star piece, right? Star says what? 4 times. Say again? Okay, so the 4. So the 4 minus 2x dx is du, right? So I substitute it completely. And that's right here, that's du. So now working on, asterisks. I could give them better names, I guess. I've got 4 times the integral of 1 over square roots of 4x minus x squared dx. So on this one, I have exhausted my list already. I know a u sub won't work now because I've already did it, and it worked for the half of my integral, but not the other half. So my only thought now is it's got to be an inverse trig. I've gone through my list, right? It's got to be an inverse trig. Well, which one though? Well, I'm only giving you 2, arcsine or arctan. This one is arcsine. I know that if y equals the arcsine of u, y prime is 1 over u prime over square roots of 1 minus u squared. So I kind of see that, right? I kind of see that. Well, the square root's giving me the hint that it's arcsine, right? For sure. The negative helps too. The negative that's in between them, that helps too. So I'm right. And remember, I've got probably that box on my formula sheet for my quiz or my test. So you're using that as a little. What's the conversion for the Egyptian writing to English? What's that cartouche called? What, the Rosetta Stone? Yeah. So you got a little Rosetta Stone on your desk with you, trying to figure out what the hell am I supposed to do, right? So inside, I know I'm probably going to have to complete the square, just because that's on my list. Complete the square, right? So I do that by factoring out the leading coefficient of x squared, right? I want positive x squared. I find half of my x coefficient, so my x coefficient is negative 4, half of it is negative 2. I square that, I get positive 4, but I have to cancel it. And so what should I put outside? Yeah, that's the thought, but it's actually positive 4, because this is, if I distribute that negative back to that, I get a negative 4. I have to cancel what I did. A good thing to do when you're practicing this is simplify this. Go backward, simplify this, and see if you have the original. That's what you want to make sure you're doing. And then you know you've completed the square, so that's got to be x plus half of the x minus 2, because that's what half of my x coefficient was, quantity squared. And again, right here, distribute that out, distribute the negative, add like terms, make sure you have the right thing. But I can start working on star now. I've got 1 over 4 minus something squared, right? So you can see I'm getting closer to, square root of, right? I'm getting closer to that 1 over 1, square root of 1 minus u squared. That's what I want. Well, what don't I like here? Looking at the box here, and my problem. What don't I like in my problem? Well, I don't like all of it, the 4, right? So I'm going to divide by 4, but that's inside of a square root, which means if I'm dividing by 4 inside of a square root, outside of the square root, I'm dividing by 2. Inside the square root, I'm dividing by 4. The square root of 4 is 2. Outside the square root, I'm dividing by 2. So I have 2 times the integral of 1 over the square root of 1 minus something squared. And that's what remember, I want that. I want 1 minus u squared. Oh my God, look how long this problem is so far. So I still have to do a u sub here. I'm going to let u be, I remember I want 1 minus u squared, so what's inside there has to be u. And that means du is 1/2 dx. So I certainly can make that happen by dividing by 2 and multiplying by 2. Oops. Right? I wanted 1/2 dx. So I can make that happen by just multiplying by 1/2 and multiplying by 2 to cancel it. So if you look at what I have now, 4 times 1 over square root of 1 minus u squared du, which is cool because I know that's arctan, arc sine of u, right? So that's arc sine of u, x minus 2 all over 2. So I finally have the full answer. Right? The original integral, don't tell me. X plus 2 over square roots of 4x minus x squared dx is now hashtag plus asterisk plus c, and it's kind of nice if you actually put it in. I'm going to put my 4 arc sine first, minus the square roots of 4x minus x squared plus c. I just rearrange it so I write one less sign, sign, right? If I kept the square root first, it's a negative, then I'd have to write plus for the arc sine and plus c. This way, at least I'd write one less character. Is that something along the lines you wanted, Brian, there?
Yeah.
Say again?
We just simplify to get it.
Yeah. I mean, it's a lot of work, and it's confusing at first, you know. But and so when I give you my test, there's one like an arctan on one test. There's an arc sine on another test, and you make sure you do everything. That's all. You have to be writing. You have to be on paper. You have to be baby steps on paper. Okay? You can't just think about things. You've got to actually build something. Okay? You got to put a nail into a piece of wood. You can't just talk about it. Okay? So you got to be writing, and you should have trouble. I did. I had trouble. But that's the part of it. That's the game that makes it fun. If it's not fun, like I said, if you're a computer scientist, you can just hack. You don't have to go to school. You can just hack, or you could just create, right? You could create your own software that could change something in the world, make texting even faster. I don't know how it could be faster, but you know what I mean? Yeah. I mean, I'm hoping one of you finally figures out how we could charge our devices from the cloud. That would be sick if we could do that. We'd never have a low battery, right? Yeah. You know how you get a little nervous when you're down to like 4%? Are you like that at all? You get nervous at 30. I get nervous once the little yellow light goes on. That's when I'm nervous. 20%, I guess. Anything else for homework that you want me to do?
I got pretty sure it was right.
Which one?
It was it's a really easy one.
I don't mind.
The little X.
The integral.
Oh, yeah.
Is it a number that you're looking at?
Oh, I said.
Okay, go ahead. The integral of this, and this is why I want the photo, so you don't have to try and say to me that little weird S thing, right? I can just look at the phone and. Okay, go ahead. Integral of. Say it again. Integral of what?
DT.
E raised to the e to the t.
No, it's DT.
Oh, okay. dt. Yep.
Over 1 minus 16.
Quantity to the ninth.
Yeah.
Yeah. So good. I like to think. I always write in x's. So I'm going to write 1 over 1 minus 6x quantity to the ninth dx. Doesn't matter what variable I use. I tend not to like the t's. They start to look like 4s sometimes to me. So I'll do everything in x's. The book will change variables all the time. T, theta, u, right? So clearly an inside, right? Yeah. So u is going to be 1 minus 6x. And of course, du is negative 6 dx. So I'm going to have to multiply by negative 6 and divide by 1/6. Because I want to change into u, right? I want to change into the variable u. So I need a negative 6 dx. And I can always make that happen by multiplying by 1. So now I have minus 1/6 of the integral of 1 over u to the ninth du. Teddy, if you can for me, log into Blackboard and see if you got my announcement. It's the PDF of our textbook, right? And did you get into WebAssign? Okay, do that for me today, okay? Again, on WebAssign, you'll have 2 free weeks of access. Some of you, if you had calc last semester, might still have some time left on, depending on what you purchased on WebAssign. And I would say let that ride until it tells you, hey, you're expired. And then you're buying the cheapest version you can. And I believe there is a 1-month version. That's all you would need after the 2 weeks, because our class is 5 weeks and you get 2 weeks free, okay? No, the problems on the website are optional. Some students like it. I personally hate it. You're going to be handing in homework that I will grade like it's a quiz. Of course, you'll have it all right? Because you have a whole weekend to do it, and you can check it on anything or everything. But on WebAssign is the project, right? So you definitely need it to do the project, and you need the textbook. I can't just give you a free textbook; it's illegal. But since you're signing up for WebAssign, I'm okay with giving you the PDF that I found on the web. I probably will get in trouble eventually when they figure it out, especially because I just emailed it to you through the school system. But I just personally, I'd rather have a physical textbook. That's just me. But I'm old. And the thing is, when I'm getting frustrated with the work, I can throw the book. And it feels good to throw the book sometimes. But you don't want to throw your tablet or your laptop, right? So you get a little bit of physical retribution if you have the book. All right, so I want to keep going. This is just a power rule here, right? So this is minus 1/6 u to the minus 9th, and I'm going to add 1 to the new power, divide by the new power, right? Plus c. So it looks like I get negative 1/6 u to the minus 8th, minus 8 over minus 8. So it looks like I get 1 over 48 u to the 8th plus c. Say again? Nope. You gotta, and so you gotta let things happen. Do our process, and let things happen. In the only way it would be an ln out of this is if my entire downstairs was the u. Right? Do you see that? If u was 1 minus 6x quantity to the 9th, now I'd have a 1 over u. But what's this du? 9 times 1 minus 6x to the 8th times another negative 6 dx. Definitely I don't have that. Right? So don't force things to happen, let them happen. Right? And I tried to really kind of spell out what's going to happen as you try each thing. Every time you rewrite your integral, you're back to the beginning of the list. You're going, oh, is this something I recognize? No. Is it the power rule? Yes. Then you're doing a new problem, right? So it's kind of like the PEMDAS. You say, oh, are there any parentheses? Okay, found one, do that. And then repeat. Okay, now are there any parentheses? Right? It's the same process you're doing with this integration. Now, what should I do? And what should I be practicing doing? Taking this answer without the constant, right? Forget the constant because I don't need it, and find y prime, right? So this is u to the minus 8 over 48. So y prime is negative 8 u to the negative 7. Oh, no, negative 9, right? I'm subtracting from the all over 48. So there it is, negative, sorry. What did I do wrong? I did something wrong. I can't think of what I did. Hey, no, you see it? Brian, you see it? Yeah, here. Yeah, they cancel, but I'm trying to get back to the original problem. I made a mistake somewhere. I just can't think of it. Oh. No, that's right. Double negative is right. I'll think about it. I don't want to waste time. It's a simple derivative, so I don't know what the hell I did wrong. But I'm going to keep getting a 6 back, right? Now I get negative 1/6 times 1 over u to the 9th. I should just get 1 over u to the 9th. I don't know what I did wrong. Doesn't matter. But you got a ln out of it, but you see your mistake.
Yeah.
Yes. Okay, nice. Let me give you the homework for Monday. I didn't get my homework done, but I did send you the textbook. And remember, these problems are from the textbook. Don't take them from the WebAssign book. okay? Because sometimes they change them. So do the ones from the PDF that I just gave you. So we're doing 3.5, number 1, number 17, and number 33. So that's 3 pages of paper already. Now, if you need paper, if you don't have paper at home, I'll give you paper, okay? If you don't have paper at home, I'm going to give you paper. I don't want you spending money to school. You pay service. You pay, you won't mind. You pay like student fees. That's supposed to give you some printing privileges, and et cetera, et cetera. So if you need paper, I have it. Yep, help yourself. You're going to be handing in 10 pieces of paper. Some problems might finish on the back. If you write a problem that finishes on 2 pieces of paper, please rewrite it. Rewrite it to fit on 1 page, front and back, okay? Your name should be on every page. The problem, the section number, the problem number, the problem should be on every page. There should be some indication that you have it right. Right? Either you did the check by taking a derivative or you looked in the back of the book, right? So 3.6 is number 1, number 13, number 3, sorry, 3, number 11, 3, sorry, 5.5, 5.6, 5.7 is number 1, number 13, number 21, and 25. I wrote that one like that because 5.7 was the trig stuff and partials, right? So the first 2 are trig problems, the second 2 are partial fraction problems. Okay? Yes, 33. 1, 17, 33, 1, 3, 11, 1, 13, 21, 25. So 10 problems, 10 pieces of paper. Nice and neat, organized, stapled please, in order and stapled. Some indication that you have it right. I'm just looking, I thought I had solutions for chapter 5 somewhere. I'm looking. Oh, here it is. Odd homework solutions, math 181. And let me see if I went up to chapter 5. Ooh, I went up all the way to the whole book. So let me send you these now, okay? This one might take a little bit longer. It's pretty big file. No, I guess you got it already. And I'll put the homework in an announcement too, okay? I don't need to do that now though. But you got everything you need to get that homework done for Monday. Please feel free to email me questions about it. Um, nice. Let's do some partial fraction work. This is a review from the last thing we did yesterday. I think we could probably finish chapter 5 today, but I don't care if I have to wait till Monday to finish it. I only have 2 more sections to do. I think it's still 5.5 is all the estimations. So I have to do that. They're boring as hell. And then 5.8 we're skipping, and 5.9 is indefinite integrals, which are fun. So I'll try and break it up a little bit today between the boring calculation estimated areas and what I think is interesting is these indefinite integrals. So, oh, I think I recorded all of that. I didn't really want to, but that's fine. Nice. So still recording. Let's look back at partial fractions. Okay. And what I'm going to do is I'm going to pick up a couple problems from the textbook, hopefully that are not not the ones I assigned you. But it's kind of nice here. So I think I assigned you 25. What did I assign you? Yeah, 21 and 25. So I don't want to do those. Let me do 24. So I'm just doing some partial fraction problems, right, to kind of remind us of what we were doing last class. This thing, the downstairs factors, right? So you're definitely looking at that and going, okay, partial fractions. As soon as you see a downstairs that factors, you're thinking partial fractions. You certainly could try a U sub first, right? It's not going to happen though. So, and I tend to say to you, solve this using partial fractions. I tend to tell you what to do on the exams. So let me do this one. So number 24. So this is 5.7, number 24. And I have the integral of x squared plus 2x minus 1 over x cubed minus x. As I'm going down my list, I'm first saying, hey, is this long division? No. The numerator power would have to be equal to or a bit larger than the denominator power. Is this a U sub? Well, let me try downstairs. But it gets pretty nasty pretty quick, okay? And of course, the real issue is if U is x cubed minus x, what's du? 3x squared minus 1. And what's the issue with my numerator? I'm okay with the 3. I can get the 3x squared, right? I can get the 1. What can I get is the 2x. I can't introduce a variable unless I'm also dividing by that variable, right? And then it's trouble. Then it just gets messy, messy, messy. So this one happens to be a partial fraction problem. This is what, x squared plus 2x minus 1. I can factor out an x, and I get x squared minus 1, and then I can see I can factor that even more, right? Yeah, you with me? So each of those are linear, so I'm expecting a constant in the numerator. So I'm going to say equals a over x plus b over x plus 1 plus c over x minus 1. Say again? Yes, I am. Yep. Yeah, it goes away if I touch that bottom left corner, that little symbol, but it's Recorder is recording. Yeah, thanks. So I want to equate these, right? I'm trying to be a little bit slower today with this partial fraction stuff. I want to space out a little bit. That's a joke. But I'm going to space out because I want to multiply everything by the LCD. And notice all my multi-term pieces have been grouped or wrapped in parens because I want to just try and be careful here. I know I'm going to be multiplying by x plus 1, by x minus 1, x plus 1, x minus 1, by x plus 1, by x minus 1, by x plus 1, by x minus 1. And now the fun part, the canceling. And then being patient and rewriting, right? Being patient and rewrite. This is what I'm calling my generator. It'll get me my values of A, B, and C as I pick X values. How are we doing here? It's just a pain to stay organized, that's all. It's not like anything we're doing is difficult. And maybe the process is complicated, so maybe the process is what's on your formula sheet, right? Do this first, do this second, do this third. So it looks like we have three really good X values for us to pick, right? X is 0, X is 1, X is negative 1. Remember when we did the one at the end of class yesterday, I had to pick some values just kind of randomly. But again, I want to be smart about it. I don't want to pick 32, right? So we're going to let x equal 0, right? And so star is going to give me minus 1 equals negative a. So a is 1. Okay, so in my head, I'm going, okay, if x is 0, that's gone. That's why I'm not writing those, right? You see it? Right, and the left-hand side, of course, 0 squared is 0, and 2 times 0 is 0, so I just get the negative 1. How are we doing there? We're okay? So next one, we're going to let x equal 1. If I let x equal 1, notice that this piece is going to go, and this piece is going to go, right? So I'm going to get 1 squared plus 2 times 1 minus 1 equals c times 2. Right? I'm just plugging into the cx times x plus 1. I'm plugging 1 in there, right? So 1 times c plus 1 plus 1 times 1 plus 1, that's 2, so 2c. So it looks like I get 2 equals 2c, or c also equals 1. Say again? Yeah, they went away because if I put in 1, right? If I put in 1 here, I get a 0. And if I put in 1 here, I get a 0. So those two pieces are gone. Finally, if I let x equal -1, right, on star, I'm going to get -1 squared. Watch out for your parenthesis here. Usually that's where the mistake is happening, right? So I'm putting in into x squared plus 2x minus 1, I'm putting in -1. Obviously, the a term is going to cancel and the c term is going to cancel, so all I'm going to have is the b term, and I'm going to have -2 times a negative b. I'm just putting those, you understand what I'm doing, right? I'm putting the numbers in my head. If you don't like that, then do it the longer way, right? If you're having trouble with that. But now I want to simplify. So it looks like I get b is -1. If I make the problem right, you should get decent coefficients like this, not like 17/4 and so, you know. So, but I mean, it's not that big of a deal if you do get fractional coefficients, but I try and make it so it's not too busy. All right, you can tell this is a long problem. I've got to do all this work just to get my coefficients, and now I finally can go back and do the calculus. So I had originally the integral of x squared plus 2x minus 1 over x cubed minus x dx, and I turned that into the integral of a over x plus b over x plus 1 plus c over x minus 1. Now there is a way for you to check this, right, that you have this right. Do you want to see it? You're allowed to use Desmos on your quizzes and on your tests. By the way, if you do need a calculator for home, a TI 8384, they have them at the Math Learning Center, and you can borrow it for the semester. Sorry, real quick. There's money for you for summer 1 right now. If you need a computer, laptop, something like that, there's free money. This is the email I got from my boss yesterday. The college has money for students taking... How do I pop this out? How do I move this over? How come I can't? Let me try this. There we go. The college has money for students taking summer session 1 classes. Most students are eligible, so if you're in need of a new computer, headphones, a web camera, a textbook, they'll even pay for your textbook, WebAssign. They'll pay for WebAssign. They have all this money left over that if they don't give it away, they lose it. Don't ask me. Or any materials for your course. Encourage them to take advantage of this free money. The funds are set to expire June 13th. Okay, so here are details. I don't know the details. Where the hell do we go to get the money? Damn it. There's money hidden on campus. Let me see if let me do this. I'm going to go to the website. What did they say? Ref? H-R-E? What did they say? H-E-E-R-F. H-E-E-R-F. Yes, so it's emergency relief. Okay, here it is. Apply. There it is. So it could be, and if I look for that, if there's a place that you need my name, please feel free to use it. If you need a reference, if you need me to verify anything, okay? Here's the application. Say again? Oh, it's just there. Yeah. So here, you might need a statement from me. I'm happy to do that for any of you. So you just gotta read it, make sure you're eligible, and it could be something like, well, I haven't been working because of COVID, right? You might have to come up with a reason why you need the money. Come up with one. I could do it, right? All right, sorry about that. I was going to show you how I can tell these are equal, correct? How I got A, B, and C correct. So on Desmos, I'm going to graph my left side of my equation and my right side of the equation, and they should match up, right? So the original integral is the integral of that rational function, right? What is it? X squared plus 2x minus 1, all divided by x cubed minus x. So there's the original function. Okay, so I get a pretty good picture of it, but now I want to put in my new function. That's 3 fractions, right? Y equals, I had 1 over x, oops, I had minus, right? Minus 1 over x plus 1, and then 1 plus 1 over x minus 1. And it matches up perfectly, right? So, and you could turn one off and then the other one back on just to double check that it's right. So kind of nice, because now the integration is easy, right? This integration, I don't even need to do a u sub. I already know the answer, don't I? Just say yes. Yeah, good. So the first one is just ln, right? The second one is minus ln of x plus 1. The last one is the ln of x minus 1, and of course plus c. And we remember from pre-cal that our positive ln pieces are going to give us numerator factors, and our negative ln pieces will give us denominators, right? So I get the ln of the absolute value of x times x minus 1 all over x plus 1. So partial fractions with linear factors, the repeated linears, right? Make sure you do a couple of those. The only difference is you have to have, right? So if I had like something like 1 over x cubed, right? Now this is me just kind of making a joke a little bit. We can do this without partial fractions, right? But what would it turn into? A over x plus b over x squared plus c over x cubed. When I have repeated linear factors, I need to make sure I'm building up the power up to that x cubed, right? If I have 3 repeated linears, I need that linear up to a cube. But I also need it as a square and a first power. And again, the thought process is, what's the LCD of these 3? X cubed, right? So I have to have an x cubed LCD. Okay, let's do one with a quadratic factor, yes? So 28 is good. 26 is also fine as well. 27 is fine. I could do that. Which one do you want me to do? Let's do 28. 28 is closest to 25, which is your homework. Okay? So 28. These are annoying, but you gotta pick the right mental time for you to do it, right? Like my brain works the best at 5 in the morning. So if I'm trying to do a really complicated problem, I'm trying to do it when I'm at the best concentration level, right? If your house is crazy, kids running around the house, how are you going to focus, right? I used to always have to stay at school and study. So I've got x squared minus x plus 6 all over x cubed plus 3x. This one is interesting in the fact that the numerator factors as well in this one, right? But I don't think I really care about it, but I'm going to do it anyway. So upstairs, I know I get x minus 3 and x plus 2. Oh, no, that's wrong. It doesn't factor, right? Factors a 6 that add to negative 1, but it's a positive 6, so nothing. Doesn't factor, sorry. But I can factor out an x, and I get an x squared plus 3. So I've got a linear factor and a non-factorable quadratic. Is that true? Oh yeah, it would have to be a negative for me to be able to factor that, right? So I get an a over x plus a bx plus c over x squared plus 3. Again, case 4 is repeated quadratic pieces, so good. Finish this one for me. Get me the a, b, and c values, please. This one is a little bit funky in that I'm going to get a value for A, but B and C are going to have to be another problem. I'll get a system of equations. Anybody get A is 2? Nice. And then you're going to get 2 equations for B and C. Yes. It kind of always gets crazy like this when you're doing, no, I can make it bigger if you need it. When you're doing this case 3, case 4 is worse. So why did I pick 0, 1, and 2? I picked 0 because I knew it would kill something. I picked 1 because it's easy. I picked 2 because it's easy, right? I know I have to plug 2 into everything, right? So anybody get to this point? Now, once I get my system for B and C, I wrote it, right? So you can see my system. I just wrote it and then subtracted them to get B is -1. And then I did a linear combination, right? I multiplied the second equation by -2 and added them and got C is 1. Sorry, C is -1. Is that right? Negative C equals 1. Yes, C is -1, sorry. So I got B is -1, C is -1, A is 2. No, is it okay? Do you need me to zoom or anything? Okay. So I've got now the integral of x squared minus x plus 6, that quantity over x cubed plus 3x is now 2 other integrals, right? The integral of 2 over x dx, okay, that part's easy, plus the integral of -1x minus 1 over x squared plus 3 dx, right? Because I got a bx plus c. I got -1 for b. I got -1 for c. Yes, you with me? This can be double checked, right? This can be double checked. You got A and B right, A, B, and C right, right? The key is if you do the 2 graphs and they don't match, you don't panic. It's usually just a simple error, like a sign, S-I-G-N. I'm saying that one you might be able to find. If you practice these enough, you'll be able to quickly look back at your arithmetic and make sure you didn't make an error. I know this first integral is just 2 times the ln of x. And the second interval, I'm going to have to do a u sub, right? So, but I can see I can factor out a negative in the top for sure. And it looks like a u sub because there's a clear downstairs, right? U equals x squared plus 3. Du is 2x dx. So I'm going to need to multiply by 2. Don't let me go too fast. If I'm going too fast, don't let me do it. I have a gut feeling I'm going too fast because I don't see a lot of you writing, and that's fine. But if I'm going too fast that you can't copy it or can't do it yourself, you got to talk to me, okay? Everything okay here? Any worries? What do I have now? I have, sorry, 2x plus 2 all over x squared plus 3 dx. And what am I going to have to do? Do you see it? And Ryan, this is a good one for us because we're having arctan in here too. Are we okay here? Am I going too fast? Baruch, what'd you say? You with me? Yep. It did. It's half of what, though? What's my numerator? Yes. And again, I'm skipping those steps and keep asking if you don't see it. And then and usually at this stage in our mathematical careers, we all go, oh, yeah, of course. And that's fine. There's nothing wrong with asking. So we can simplify some things here, and we will. What do you think can happen to the first term? What can happen to this first term? 2 times the ln of absolute value of x. What does that 2 really mean for a log function? It's the coefficient of a log function is the exponent of the argument, right? So I'm really talking about ln of the absolute value of x squared. And now you're saying, well, do I need the absolute value anymore? Hell no, right? And what about this other one? Well, x squared plus 3 is positive, so I don't need that absolute value. And you see, I'm just trying to do little baby steps as I rewrite my whole thing. So now I could say this is the ln of x squared minus the ln of the square root of x squared plus 3 minus that last integral, which is going to take me just a tiny bit of work. But you can see I can do something with these two integrals, right? The first two answers, sorry, I could do ln of x squared over square root of x squared plus 3 minus this last integral. And you'll see sometimes I'm choosing to write the integral over and over and the answer over and over again. Sometimes I'm working just on pieces. It's your choice. just stay organized and make sure your final answer is clear. What's this last one? What's this last integral? Right, so I'm really looking for that, right? I want a 1 plus u squared, not a 3 plus x squared. So I'm going to divide everything by 3. Make sure you agree with me there. Yeah, so now square it for me. Do you see I get x squared over 3?
Yeah.
Yep. So often easier to go instead of doing it the way I'm doing it, go back from what I got and then take in that trick, right? So if u is x over rad 3, du is 1 over rad 3 dx. And I actually have that. Right? Rad 3 times rad 3 is 3. So now I finally have 1 over 1 plus u squared du. Wow. Huh. Just got to make it a game, make it fun, somehow. Practice, ask for help. If you've been out of work because of COVID, if anything, the family is tight on money because of COVID. You could get the school to pay for your summer class. You can get the school to pay for your webassign. You could, if you're in a class, if you're in a household with only one computer and you have to do schoolwork, you can get a computer. They have the money. Reach out to them and feel free to use my name as a reference. Okay? Cool. How do you feel about partials? Tell me the truth. You haven't done any yet, right? And then it's a little bit annoying. Get over it. No. I like to say math is like jail. If I'm in jail, I got no choice. So what am I going to do? Sit there and be miserable, or am I going to exercise and read and you know what I mean? The worst situation, you've got to be positive. Oh my God, this problem's going to take me 4 pages, and I got to do it. You can't go in it like that, right? You got to make it a game. If my nephews say, "Hey, do you want to play Monopoly?" and I'm miserable the whole time, what the hell's the point? So you could be the banker and cheat and steal money, and you know what? Make it fun, right? I don't know if you know Monopoly, but it's some stupid game. Cool. Let's take a little break. Let me stop this recording.